So we had problem number 1, and I had letter A, and it was to find the equivalent capacitance for the combination of all the capacitors in the circuit. And in the beginning, I started internally. I started with the most internal ones, which is 1 and 2, and they're in parallel. So you can use the rule of C12, which would be the combination of the two, equals the capacitance of 1 plus the capacitance of 2, which is 20 plus 50 equals 70. So you can simplify it down to this circuit. So I went to the next branch here, so I'd combine 3 and then capacitance of 1, 2. And since they're in series, you do the inverse. So the inverse of capacitance 1, 2, 3 is the inverse of capacitance 1, 2, or capacitance 1, 2, and then capacitance 3. When you add those, you get 7 over 210 and 3 over 210, and when you simplify it, you get the capacitance of 1, 2, 3 is 21 microfarads. And that simplifies it down to this circuit. So when you find 1, 2, 3, you have 4 and 5 next, and you want to get them combined into one. And they're in series, so you can do the inverse rule again, and when you do the math, it comes out to be 15 microfarads. So now you have capacitance 4, 5, and capacitance 1, 2, 3 in parallel. So you can use the additive rule again. So you take the capacitance of capacitor 4, 5 and capacitor 1, 2, 3, which is 21 plus 15, and you get 36 for 1, 2, 3, 4, 5. So once you get the capacitor 1, 2, 3, 4, 5, you see that they're in series with capacitance 6, the capacitor 6, and you use the inverse rule one more time, and when you do the math for that, you get 12 microfarads.
So part B of our question asks for capacitors when they have the same voltage. And we know that when capacitors are in parallel, they have the same voltage. We know that because voltage can't divide up, so the charge must divide up to compensate for the voltage given by this. And so going back to our circuit, we know that because these two are in parallel, they will have the same voltage.
Okay, for our capacitors in series, our formula is 1 over C equivalent equals 1 over C1 plus 1 over C2. This leads us to show that C1 and C2 will have the same charge. This is because you can see over here, all the charge that passes through capacitor number 4 has to pass through capacitor number 5. It has no other route to take.